So at AUM, we have actually a very interesting pipeline of multiple drugs. The one drug that we are leading with, our lead candidate, is what's called a MYC1/2 inhibitor. MYC is a critical enzyme in the steps that's taken from RNA being translated into protein. And so inhibition of MYC basically will interfere with that key step where you go to the early stages of protein formation. The reason why we actually like MYC, and the key reason for selecting it, is that one of the problems when you're treating cancer cells is that if you try and inhibit any particular point in a pathway, the cell can very quickly figure out how to bypass that and become resistant. If we have something that is at a very critical point in the pathway though, which is the RNA to protein transition, then it's very hard for the cell to figure out a way to overcome that resistance, to overcome that particular block that we're putting in there. And so that makes it a major area that we want to play in. The other beauty of doing this is that all pathways feed together into that RNA to protein translation. So we are able now to not just say that we will inhibit one pathway, but we can actually target multiple pathways all feeding into one area. And that's something we actually refer to as choke point inhibition. So in cancer, one of the biggest challenges that we face is that we cannot cure cancer for the most number of patients, the majority of patients. There are a handful of cancer types where you truly have curative therapies, but you can count it on the fingers of one hand, basically. So anything that we throw at cancer cells, the cell ultimately becomes resistant and the cancer will recur. And what we are aiming to do with our approach here is to find ways to ideally cure cancer, but I think that's a long-term goal. But the more realistic short-term goal is that we meet the unmet medical need of making cancer into a chronic disease. So we now want to effectively make cancer behave like somebody who has hypertension or somebody who has diabetes. You take your medicines, you live a long time. We want to move it away from being a killer to being a stable or chronic disease state. And by doing that, you can now prolong the patient's life and keep them comfortable. The other thing that feeds into it, and that also is a key unmet need, is that this has got to be done without making the patient feeling very sick. Right now, most of our therapies in cancer have significant toxicity. You lose hair, you get nauseous, you lose weight, you don't want to eat, and fatigue actually is a major problem. The patients are just dragging. They can't do anything. We aim to develop drugs which actually have minimal to no toxicity, and that gives us the advantage of taking out of the equation that fatigue and all the other side effects that would make the patient's life miserable, because now we want them to live longer, we don't want them to be miserable and living longer. And by also having this relatively low level of toxicity, we are able to combine with other drugs, and so we can now have combination approaches. And when you have combination approaches, the outcomes are better in cancer.